Look at this image. At first glance, it looks like a star, a glowing, violent ball of gas. But as the James Webb Space Telescope zoomed in, the data began to scream one word: impossible. This is 29 Cygni b. It weighs 15 times the mass of Jupiter. According to our current understanding of physics, something this big shouldn't be a planet. It's right on the forbidden line where a planet is supposed to become a star. But it didn't. It's a failed star that is somehow acting like a giant planet, and its existence is forcing NASA to rethink everything we know about how worlds are born. Welcome to the identity crisis of the cosmos. Welcome to the mystery of 29 Cygni b. For decades, astronomers believed there was a clear boundary. On one side, you have planets, born from the bottom up inside a disk of dust and ice. On the other side, you have stars, born from the top-down collapse of massive gas clouds. It was a neat, orderly system. But in April and May of 2026, the James Webb Space Telescope shattered that order. Using its NIRCam instrument, JWST directly imaged 29 Cygni b, a massive object 133 light-years away. And what it found was a geochemical nightmare. You see, if 29 Cygni b were a star, it should be made mostly of hydrogen and helium. But the chemical fingerprints caught by Webb show that this monster is packed with heavy elements, carbon, oxygen, and metals. It has 150 times more heavy elements than Earth. This tells us one terrifying thing: this giant didn't form like a star. It grew bottom up, greedily devouring metal-rich rocks in a protoplanetary disk until it reached a mass that should have ignited it into a sun. But it never lit up. It stayed dark. It stayed cold. It became a superplanet that defies the very laws of gravity that govern our own solar system. How can an object this big form through accretion? In our computer models, the moment a planet gets this large, it usually triggers a runaway reaction that turns it into a star. 29 Cygni b is the absolute limit of what a planet can be. It is the end of the road for planetary physics. But the mystery goes deeper. When scientists looked at its orbit, they found it was perfectly aligned with the spin of its parent star. This is the ultimate smoking gun. It confirms that this monster was born from the same disk as its star, behaving exactly like a sibling planet, but on a scale that is nearly incomprehensible. If objects like 29 Cygni b are common, then our search for alien life just got a whole lot more complicated. Imagine a world with the gravity of a star but the surface of a gas giant. A world where the atmosphere is thick with carbon dioxide and metallic clouds, swirling in a permanent infrared glow. These aren't just big Jupiters, they are a completely new category of celestial objects that we are only beginning to name. We used to think the universe had rules. We thought there were planets and there were stars, and never the two shall meet. But 29 Cygni b is proof that the universe loves to blur the lines. It is a glitch in the matrix of star formation. As the James Webb mission continues to scan the Cranium Nebula and beyond, we are realizing that the early universe was far more creative and far more dangerous than we ever imagined. We are finding little red dots that shouldn't exist, ghost galaxies that have stopped spinning, and now, superplanets that think they are stars. We are living in the golden age of discovery, but every answer we find only leads to 1,000 more questions. Is our own solar system the exception, or are we the only ones following the rules in a galaxy full of monsters? What do you think 29 Cygni b really is? Is it a planet that pushed the limits too far, or a star that simply forgot how to shine? Let me know your theories in the comments. I want to know if you think we need a third category for these star-planet hybrids. If you want to stay on the cutting edge of the discoveries that are breaking our reality, hit that subscribe button right now.